Hello everyone, I hope you are doing well today. My name is Ahtesham Shaikh and I am currently pursuing my MCA at Vishwakarma University. In this video, I will be walking you through the architecture of a data warehouse, a key concept in the world of data management and analytics. Whether you are new to data warehousing or looking into spreading your knowledge, this video will cover everything from the core components to the types of schemas and the importance of metadata. So let's dive in. To start, let's define what a data warehouse is. Simply put, a data warehouse is a centralized system used for storing and managing large amount of structured data from multiple sources. It's designed specifically for analytics and reporting, not for day-to-day transactional processing. The primary goal is to provide business intelligence by analyzing data that has been accumulated over time. This data can be used for various purposes, such as forecasting trends, improving decision making, and supporting strategic goals. A data warehouse acts as a central repository where data from different operational systems are consolidated, cleaned, and organized for easy analysis. One of the main advantages of a data warehouse is that it stores historical data, which is essential for performing detailed analysis and uncovering trends. It also helps business in predictive analytics, where we can forecast future events or behavior based on the data we already have. Data warehouses are heavily used in industry like finance, retail, healthcare, and logistics, where large amounts of historical data need to be analyzed regularly. Now let's explore some key characteristics of a data warehouse that make it stand out. First, subject-oriented. A data warehouse is designed to focus on specific business areas such as sales, finance, or marketing. This makes it easier for users to query and analyze data related to particular business needs. Second, integrated. It brings together data from different sources which can include internal systems, external data sources, and even cloud services. This integration is crucial for providing a unified view of the organization's data. Third, time variant. Data warehouse store historical data, which means they keep a record of data over time. This allows business to perform trend analysis and look at changes in their data over the years. Fourth, non-volatile. Once the data is loaded into a data warehouse, it is not altered or deleted. This ensures that user can always rely on the data for consistent and accurate reporting. Now let's talk about the core components of a data warehouse. There are five main parts that work together to form the foundation of the system. First, source system. These are the operational databases and external data sources that provide the raw data. This could be anything from sales systems to social media data. Second, ETL, extract, transform, load. The ETL process is responsible for extracting data from the source systems, transforming it into a usable format, and then leading into the data warehouse. This process also includes cleaning the data to ensure it's accurate and consistent. Third, data storage. This is where the data resides in the data warehouse. It can be stored in relational databases like SQL databases or even cloud-based storage solutions. Metadata. This is the data about data. Metadata describes the structure of the data warehouse, including how the data is organized and the relationship between the different data sets. It helps user understand the data better. 5. OLLP. Online analytic processing. OLAP tools are used to analyze and query large amounts of data in the data warehouse. They allow for multi-dimensional analysis and provide insights that support decision making. Now let's discuss different types of schemas used in data warehouses. The schema design plays a huge role in how efficiently data can be queried and analyzed. Here are three common types. First, star schema. In this design, there is a central fact table that stores quantitative data like sales or revenue. This fact table is connected to multiple dimension tables that store descriptive data such as product details or customer information. It's simple and easy to use. Second, snowflake schema. This is more normalized version of the star schema. It breaks down the dimension tables into additional subtables. It can improve data storage efficiency but might take querying up more complex. Third, fact constellation schema. This design involves multiple fact tables that share common dimension tables. It's often used in complex analytical environment where more than one type of analysis needs to be done using different fact tables. Now let's take a closer look at the two main types of tables in a data warehouse: dimension tables and fact tables. Dimension table. This table contains descriptive information. For example, a customer dimension table might store data about customers such as their names, location, and contact details. Fact table. This table stores numeric data that can aggregated such as sales, amounts, quantities sold, or profits. They often reference dimension tables to give context to the numeric data. Additionally, there's something called a fatless fact table, which records events or activities but does not contain numeric measures. This is useful for tracking events like customer visits or product shipments. Granularity in a data warehouse refers to the level of detail stored in a data. For instance, high granularity means storing data at a detailed level, such as high each individual transaction. While this gives a lot of insight, it can be more resource intensive and may slow down queries. Low granularity involves summarizing or aggregating the data, like recording daily totals instead of individual transactions. This is more efficient for large datasets but may lose some of the detailed insights. The choice of granularity impacts both query performance and storage requirements, so it's important to strike the right balance based on your needs. Let's now discuss metadata, which is often called data about data. Metadata help us understand the data in the data warehouse by providing information about its structure, the source of the data, and any transformations that have been applied. There are three types of metadata. First, technical metadata describes the structure of the data and how it's stored in the warehouse. Second, business metadata provides business rules and key performance indicators that help user interpret the data. Third, operational metadata contains information about how often the data is refreshed or when it was last updated. Managing metadata is essential for ensuring data consistency and traceability. It also helps in meeting regulatory compliance requirements such as GDPR or HIPAA. Many organizations use tools like Informatics, Talent, and Colibra to manage their metadata and ensure data integrity. Effective metadata management improves data accessibility and helps users make better decisions. In summary, data warehouses provides a wide range of advantages. They speed up decision making by allowing quick access to historical data. They improve data quality and consistency, and they enable advanced analytics like predictive modeling and AI. Data warehouses are used in various industries like finance, healthcare, retail, logistics, where they help organizations uncover insights, improve performance, and drive business growth. To wrap things up, data warehouses plays a critical role in modern business intelligence. They allow business to store, manage, and analyze vast amount of data to make informed decisions. The combinations of ETL processes, metadata, and well-designed schemas enables organizations to manage their data more efficiently. Thanks to data warehouses, we can derive valuable insight from historical data and use them to shape the future. And that wraps up our discussion on data warehouse architecture. I hope this video helped you understand the key concept from its component to schemas and metadata. Their data warehouses are a game changer for businesses, making data analysis and decision making much easier. Thanks for watching.